Alright, so today it says I can use function notation to evaluate a function and create a table. So a function is something that we can graph. And what we're going to learn how to do is we're going to learn how to plug into function notation. We're going to create a table. We're going to graph things. It's going to be awesome. Are you ready? If you're not ready, can you hustle?
The face. She's just like.
Why are you making that face?
Because why not make that face?
I don't know why she was making that face. She was just looking like she was about to be murdered back there. Oh, and your brain worked for the first time in a while and you were surprised?
When you was in high school, did you ever throw shade? I feel like.
No, never.
No.
Was it?
I don't know what thing. She had your hands go. You were fine. She was like, you know what? Get out the class.
It's recording. Everyone has hands, except for people who are pirates, and they have a hook.
No, see, even the pirates that do have a hook, they still have hands. They just have a little guard over their hands, and they just hold it like that.
Okay, so, holy cow. Function, machine, and function notation. So a machine is something that you plug things into, and you get stuff out, and magic happens. So what we're going to talk about is a function machine. So a function can be thought of as a machine. That assigns one x value to every y value. And isn't that the definition of a function? Look at us go. We have special parts of function notation. So this right here, this is called function notation, and it's the same thing as if you wrote y. If we wrote y equals 3x plus 4, it would be the same thing, but we're fancy and we're going to write f at x. So f is the name of the function. So do you see how you have an x in parentheses and then an x over here? And we know that we plug in our x values. So this x tells what number to plug into the function. So if I wrote f at 3, what would I plug in for x over here? 3. And if I wrote f at 2, what would I plug in over here? And if I wrote f at negative 6, what would I plug in over here? And if I wrote f at Oreos, what would I plug in over here? So whatever you put in here, you plug in over here. Does everybody understand? I don't even know what just happened.
Someone said they didn't like Oreos.
What is that?
That triggered.
Let's see a gun. Alright. So again, f is the name of the function, and f at x means f is a function of x. And you say it as f at x. Or f of x, either one. So it's where the function is at the x value, which is why f at x is the same thing as y. They are the same thing. This part is the function. Isn't it magic? Is that air on cold? Can you open it and see? Oh, can we turn it on cool?
All the way.
Thank you.
All the way.
Alright, so now what we're going to do is we're going to plug in f at 2 and f at negative 1. We're going to use our little function machine right here, and we're going to see what happens. Are you guys ready?
Yeah.
So, we're plugging in 2 into the function, which means that we would write f at 2 equals, no, out, 3 times 2 plus 4. Do you see how I replaced the x with the 2? Isn't it magic? And remember, we're still using the same machine from up here. What is 3 times 2?
6.
And what is 6 plus 4? So f at 2 equals what? 10. Dun, 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 dun. That's all you do. It is. You plug in negative 1 without me. What did we get?
We gotta fix that waffle. We're not done.
We're not done yet.
I got one.
I got 1 as well. How did we get 1? Okay, so what they were muttering is 3 times negative 1 is negative 3. Negative 3 plus 4 is positive 1. Cole and Whitney, are you with me? Awesome. Alright, are we ready to see what's inside our magic foldable? Open it up. Okay.
She said a random word.
Alright, so we have 2 different functions. We have f at x and we have g at x. So we're going to plug in 3 into f here and 3 into g here. It tells you what function to plug it into. Does everybody understand? And if you want to make your machines look beautiful, you can. You can write f at x equals x squared plus 3. That's our first one. And our second one is g at x equals x plus 1. Are y'all ready? So for f at 3, I would plug in 3 into x. So I would say 3 squared plus 3. What is 3 squared? And what's 9 plus 3? And boom, you're done. Does everybody see how we got this? Are you dying? Why? Okay. Yes. No. Alright, so now let's plug in 3 for g. We have 3 plus 1. And what's 3 plus 1? And boom, you're done. Can you do the next 2 without me? I know, this is mind-blowingly difficult. What number are you? All right, Hufflepuff, tell me what you got for f at -2. You got 7? How did you get 7? Tell me how. You're right. I just want you to tell me what to do. You don't know what you did? Then how did you get it?
I use calculators.
Tell me. Tell me what we do. Tell me.
-2 times -2 is 4.
Look at you go. Y'all take a point. Fantastic. All right, someone at Ravenclaw, tell me what you got for G at 0. How did you get 1?
Wait.
0 plus 1 is? Good. Take a point. Yes. For which one? This one? -2 squared is 4. You have to put -2 in parentheses in your calculator. Because it's -2 times -2, which is +4, plus 3 is 7. Alright, let's look at this one. What do you think we would do for this problem right here?
Not have our phone go off?
What do you think we would do for this problem right here? Solve both and then add. Good job, children. So you would do 2 squared plus 3 plus 1 plus 1, right? You can put it in parentheses if you wanted to and be real fancy. Alright, what is 2 squared? 4 plus 3 is? And what's 1 plus 1? And what's 7 plus 2? And what's our final answer? Look at us go. Can you do the next one without me? Do it. What did you get? You got 4? How did you get 4? Fantastic job. Take a point. Any questions so far? Okay, what do you think we would do on the next 2 problems? Kind of. Nathan?
You would do G first and then advance with it.
Take a point. You would plug in 2 for G first, and then whatever you get for this, you would plug into F. So if I plug 2 into G, what's 2 plus 1? 3. And then I'm going to plug that into F at X. So I'm going to say 3 squared plus 3. And again, where did I get this 3 from? From G. I plugged in 2 into G, and I got 2 plus 1, which is 3, and then I put that here. Now, what's 3 squared? And what's, no. Thank you. And then 9 plus 3 is? 12. Do the next one without me. Are you confused on what we did?
No.
Okay.
Oh, sorry.
You're confused what, Jackson? You're not confused? You're living the dream over there? How to breathe? How to read. Okay. Alright, alright. No judgment, all God's children. Okay, what'd y'all get?
4.
How'd you get 4? Because 0 squared is 0. 0 plus 3 is 3. 3 plus 1 is 4. Dun dun dun. Let's move on to the next one. What is happening? In the second drawer in the white basket. Okay, so for the last one, it says F at Y. On the front page, I told you that if I had F at Oreos, you would plug in Oreos over here, right? So what do you think we're going to plug in for X now? For Y. And we're going to write Y squared plus 3, and we're going to be done with it. That's it. That's all you do. For W, you plug in W, and you write W plus 1, and boom, you're done. Alright, do the next 2 without me. Or the next 3. This page. Do the right side of the page. Yep.
Do you want us to write 5 right there? That's
Yeah, you put it for the both of them. Yeah. Nathan asked a great question. He asked if we should plug in 5 for both of the x's. Yes, plug in 5 for both of the x's. Nope, I'm going to save it. What did we get for the first one? C? C. Good. What about for the second one? Are y'all saying B as in boy? Okay. And the last one? You guess? How did you guess? Because you're lazy? Okay. Can't be lazy in pre-AP. So you should do 2 times x plus 1 minus 5, correct? Okay. What's 2 times x? And 2 times 1? And then 2 minus 5? Did anybody get that one right? Oh, sorry. I got excited. Would you have gotten it right? You have faith in yourself?
Nope.
Why do you not have faith in yourself?
Because
I will. Also in the top drawer of your tower is your homework for tonight. It's the last set of pages if you want to get those out. We're going to do the back together. First I'm going to show you a trick I learned in NAM. And then you're doing the front on your own.
Every time you only have
says you
one
run the freaking
sheet.
No. It's in the pre-AP stack on the back of them. Yeah.
That would make sense.
Pardon? No, it's the algebra book broken into 2 years. So it's just if you learn at a slower pace. Yeah. Which no judgment if we do, right? So what we're going to do is I'm going to graph each of these on my handy dandy app called Desmos. Have you guys heard of Desmos?
No.
It is lovely. You can download it, but not right now. So, it graphs functions for you. It's amazing. Like, I can type in y equals x, if I can hit the button, and look, it's graphed y equals x. So now what we're going to do is we're going to take this graph on the screen, and we're going to find which one looks like y equals x on your paper. So for number 12 on the back, again, we're on the back, which one looks like that? Which letter? I. So write I beside number 12. Okay, 13, I'm going to graph 1 half x minus 1. You think it looks like, what are y'all saying? B? Yes, it does. Alright, next we're going to graph 3x plus 1. C. Good job. Alright, here's how you would graph absolute value of x. Alright, x squared plus 1. F as in Frank. Alright, y equals negative x. Alright, y equals 3. L is in Lotato. Negative 1 half x minus 1. Oops. Blair. D is in Dotato. Number 20. A. And then which graph is not the graph of a function? G is not the graph of a function. It would not pass the vertical line test. Now, another spiffy thing about this is I can hit this wheel cog thing, and I can get a table. And it pulls up a table for you. Isn't it lovely? Desmos, D-S-M-O-S. You can also graph more than one function at a time. So if I wanted to graph y equals x, and I wanted to see what happened with y equals x plus 2, so that moved it up 2, right? Isn't it magic? Yep. So now what I want you to do is I want you to finish the front. You need to plug those in. Read the directions. You can also go ahead and fill in your letters up here. We answered 12 through 21, correct? So we can fill in those letters. Why don't you do that now? I hope y'all got those right on the back, because I was just taking your word for it. like Wheel of Fortune. Yo. Happy birthday. You're not getting my car.
What kind of car do you have?
One that y'all will not ever drive. You know that people of multiple races are allowed to do that, right?
I mean, yeah, but like, there's people that feel like you black.
Okay.
You play.
That's a good
I didn't say it was a bad thing, baby.
We got a whole mama. What?
It's still recording. Alright, so you guys know what, do you have any of these problems on 1 through 11 that you want me to work out for you before you leave me?
3, yeah.
3?
3.
Okay, so what do the absolute value bars mean? That it's going to turn it positive, right? That's what I'm looking for. So you would say negative 8 times negative 3 plus the absolute value of 3 times negative 3 plus 6. All right. You might want to work these out on a separate sheet of paper, but you know, you don't have to. What's negative 8 times negative 3? 24. And the absolute value of 24 is 24. All right, 3 times negative 3 is negative 9. What's negative 9 plus 6? Negative 3, and the absolute value of negative 3 is positive 3. So the answer is 27. So that's P. 3 is P. Are there any others that you want me to do? 8? Okay. Oh, that's a good one. So 8, you would plug it into the top and the bottom. You would say 5 times negative 2 plus 1 divided by negative 2 plus negative 2. 5 times negative 2 is negative 10 divided by 0. Can you ever divide by 0? No. So this is no solution, which is the same thing as unknown. So 8 is M. Any others? You know that I'm just ignoring you, right? Okay. Pardon? 10? Okay. So 10, you would do the same thing. You would do negative 4 plus 4 divided by 4 times negative 4 plus 2. This gives you 0 divided by negative 16 plus 2. 0 divided by negative 16 gives you 0. 0 plus 2 is 2. I noticed on your absolute value inequality test that you two were confusing dividing by 0 and 0 divided by a number. You can divide 0 by a number, but you can't divide a number by 0. Like, I can have 0 people at a party and have 16 cheeseburgers, but I can't have 11 people and 0 cheeseburgers. That's not how it works.
That's my
And that would be a disappointment, so it's no solution. Unless you're the vegetarian there, and then you're okay.
And you're the disappointment.
No, I am not a disappointment just because I don't eat meat.
You're just